There was a hive on the east side of a small operation, late July, second season for that particular colony. One of the stronger ones in the yard. Good population, healthy stores, a queen that had come through winter well and been laying steadily since March. The beekeeper who managed that operation had been keeping bees for 12 years. He knew what to look for when he opened that hive and found 2 queen cells on the face of the 4th frame. Capped, developed, positioned in the middle third of the comb. He did what 12 years of experience had trained him to do. He removed them, both of them, pressed them out carefully, checked the remaining frames, found none, and closed the hive satisfied. He'd interrupted what looked like early swarm preparation. The colony would stay intact. By October, that hive was in trouble. The queen's brood pattern had gone sparse. By November, it was failing. The colony entered winter with a population too small to hold together, and it didn't come out. The hive that had been one of his strongest was an empty box by April. What he destroyed in July wasn't swarm preparation. The colony hadn't been getting ready to leave. It had been in the middle of replacing a queen whose chemical signal had been declining for 6 weeks or more. A queen the workers had already evaluated and found inadequate, using a detection system that runs continuously and reads information no beekeeper can access during a routine inspection. Those cells were the solution to a problem the colony had been working on since May. When he removed them, he didn't prevent a problem. He created one. This is the most consequential queen management mistake experienced beekeepers make. And it is almost always made by experienced beekeepers, not beginners, because beginners don't know what supersedure cells look like. Experienced beekeepers recognize them and misidentify them as something else. If you've ever found queen cells in a strong active colony in midsummer and weren't completely certain what you were looking at, stay with this. Because understanding supersedure biology changes how you read every inspection you do for the rest of your time keeping bees. Leave a comment below if you've been in that situation. I'd like to know what you found and what you decided. And if you haven't subscribed, now's a good time. The word supersedure appears in beekeeping literature often enough. Most beekeepers know it means queen replacement without swarming. That definition is accurate as far as it goes. But it doesn't tell you what supersedure actually is at the biological level, what triggers it, what sustains it, and why the colony's execution of it is more precise than anything a beekeeper typically does to replace a queen on a management schedule. The colony does not replace its queen when the queen fails visibly. The Ansit feels buys vis en par, a pan wine, the Ansit feels visibly. It replaces her when a chemical signal she produces, a pheromone complex called queen mandibular pheromone, falls below a threshold that the collective physiology of the nurse bee population has been tracking without interruption. Not daily, continuously, every feeding cycle, every grooming contact between the queen and the workers attending her carries chemical information. And that information is being read. The most critical component of the queen's pheromone signal is a compound called 9-ODA. It's produced in glands in her jaw. A young queen produces it at high levels. As she ages, those glands don't fail suddenly. They produce slightly less. Season by season, the signal gets quieter. Most accounts stop there. They describe the pheromone, note that workers detect changes, and move on. What they don't explain is the mechanism of detection, because that mechanism is where supersedure's precision actually comes from. It runs through the nurse bees, the workers in the first 3 weeks of adult life who spend their days feeding the queen, attending her, interacting with her directly. Each of those interactions is also an assessment. The nurse bee's own fat body, a metabolically active tissue that functions as energy reserve, immune organ and physiological regulator simultaneously, responds to the queen's pheromone signal at the biochemical level. High 9-ODA suppresses certain nurse bee physiological responses. A declining signal allows them to emerge. When enough nurse bees, interacting with a queen whose output has been dropping across weeks, reach a collective physiological threshold, the supersedure sequence begins, quietly, without visible drama, often 6 to 8 weeks before a beekeeper would think to question anything. That queen is still laying, still moving through the frames, still has a retinue of workers around her. Her brood pattern may still look reasonable. The visible signs of decline come later. The nurse bees reached their conclusion in May. The beekeeper opens the hive in July, sees a laying queen, sees a functional brood pattern, sees queen cells, and concludes that something triggered swarm preparation. He removes the cells. He closes the hive, confident he's corrected a problem. The queen he left in that hive was already on the decline. The bees had known it since the spring build-up. That's the part that trips experienced beekeepers more consistently than beginners, because experience without the biological context behind it teaches pattern recognition built on the wrong frame. Queen cells mean swarming. Remove them, the colony stays intact. 12 years of that reflex, applied without discrimination, is how a beekeeper destroys a supersedure sequence without knowing what he's done. Now, if the colony initiates supersedure, where it builds the cells is not incidental, the location is one of the clearest diagnostic signals available to a beekeeper who knows how to read it. Supersedure cells are built on the face of the comb, the middle third of a frame, sometimes higher, drawn perpendicular to the comb surface. One cell, occasionally 2 or 3, rarely more than that. Swarm cells are built along the bottom edges of frames, in clusters, often 10 or more, hanging from the lower margin of the brood nest. The reason supersedure cells are where they are has nothing to do with construction convenience. The center of the brood nest is the most thermally stable zone in the hive. Brood temperature is maintained in a narrow range, 93 to 95 degrees Fahrenheit, and the center frames hold most consistently within that range. They also carry the highest concentration of nurse bees in the colony. The nurse bee density at the center of the brood nest can be 3 to 4 times higher than at the outer frames. Royal jelly feeding during the larval stage is what shapes queen quality directly. Her mandibular gland development, her ovary structure, her subsequent pheromone capacity. The colony places a supersedure cell in the center of the frame because that is where the developing queen will receive the most continuous, highest quality nurse bee attention available anywhere in the hive. The placement is not convenient, it is deliberate. One cell on the face of the frame. Center of the brood nest. Compare that to the bottom bar clusters of a colony preparing to swarm. The distinction is visible and meaningful. A colony building swarm cells is producing multiple queens for reproductive redundancy. It doesn't need to optimize each one. A colony in supersedure is producing a single queen who has to carry the colony forward, and it is putting her in the best possible developmental environment. Here is where the biology surprises most beekeepers, and where experienced beekeepers most consistently make the second mistake after the first one of removing the cells entirely. When a supersedure cell is capped and the replacement queen is developing inside it, the original queen doesn't stop laying. For when supersedure cell is capped and the replacement queen is developing inside it, the original queen doesn't stop laying. In most supersedure sequences, the colony keeps the existing queen functional and productive throughout the entire period, while the new queen completes development and mating flights. 2 queens, same hive, both laying, often occupying different sections of the brood nest. Most beekeepers who open a hive during this phase and find 2 queens respond in one of 2 ways. They remove the older queen because they assume the situation is unstable and needs resolution, or they remove the younger queen because they don't recognize her as the supersedure replacement and assume she emerged from a cell they missed earlier. Either intervention disrupts a process the colony is managing with more precision than the beekeeper is providing. The dual queen phase exists because the colony is not certain the new queen will succeed. Mating flights have risks. Weather can close in. A young queen can be lost. By maintaining the old queen's productivity through the transition period, the colony hedges against that possibility. Brood rearing doesn't stop. If the new queen fails to mate or return, the colony still has a functional laying queen and can initiate the process again. Remove the old queen during this window, and you eliminate the insurance. The new queen's mating period is 7 to 10 days under favourable conditions. If anything goes wrong in that window, the colony has no recovery pathway. 2 queens, colony calm, brood in multiple stages. Close the hive, come back in 3 weeks. The transition will almost certainly have resolved itself. The old queen will be absent or clearly secondary. The new queen will be establishing her pattern. That is the biology completing what it started. GM Doolittle, whose work in scientific queen rearing through the 1880s and 1890s produced the most careful queen quality documentation available from that era, wrote about this pattern across multiple seasons. His observation was direct. The queens that colonies raised through Supersedure were consistently better than the queens he produced through artificial grafting and introduction. Not always, but consistently enough that he considered it a principle worth understanding. His reasoning was precise. A Supersedure queen was raised from a larva selected by nurse bees who had been monitoring the pheromone decline of the queen she was replacing. Those same nurse bees provided the royal jelly that shaped her development. The cell was positioned by workers who had been living with the declining queen through whatever conditions had brought her to the threshold of replacement. The selection criteria were specific to that colony, that season, that particular combination of factors. A.I. Root observed the same pattern. The commercial beekeepers of the Ohio operations from the early 20th century, who kept records careful enough to track queen performance across seasons, saw it too. Colonies that completed Supersedure without beekeeper interference showed strong subsequent brood cycles. Colonies where the beekeeper had intervened, removed cells, introduced purchased replacements, disrupted the coexistence phase, showed higher rates of queen problems in the seasons that followed. If this kind of historically grounded reasoning changes how you think about what's happening inside your hives, subscribing is the best way to stay with it. More of this ahead. The queen replacement industry that developed through the mid-20th century had no commercial interest in that observation. A beekeeper who trusted the biology and left Supersedure cells alone was a beekeeper who didn't need to order a replacement. The advice that moved through commercial beekeeping channels during that era directed attention toward the queen as a product to be managed on a purchase schedule. Replace annually. Remove cells found in production colonies. Treat any sign of queen preparation as a disruption to be corrected. That advice wasn't fraudulent. It was incomplete in a way that happened to be economically convenient, and the practical knowledge of experienced beekeepers who had watched Supersedure sequences complete, who had seen the quality of the resulting queens, had no commercial voice and quietly disappeared. Practical application today follows directly from the biology. When you open a hive and find 1 to 3 queen cells on the face of a brood frame, in the middle third, not the bottom edge, with the existing queen still present, and the colony otherwise organised and calm, you are looking at Supersedure. Note the cell locations. Verify they are capped and developing. Close the hive. Return in 28 to 32 days. That is the window for a Supersedure queen to emerge, complete mating flights in favourable weather, and begin establishing her brood pattern. If you return and find a young queen with a fresh, tight pattern, the transition succeeded. Leave it alone. If you find 2 queens still present, the coexistence phase is still completing. Leave it alone for another 2 weeks. If you return and find the colony broodless with no queen visible, the Supersedure attempt failed. Weather, predation, some disruption during mating, and now you have a management decision to make. That is the moment intervention is warranted. Not at the beginning, at the end, if the natural process came up short. The colony that you found those cells in, the one that had the problem since May, had already done the hardest work by the time you lifted the first frame. The nurse bees had been running the assessment for weeks. The cell placement was deliberate. The coexistence phase was managing a biological risk that no beekeeper calendar accounts for. All of it was already underway. The bees were 6 weeks ahead. The queen they were producing would have been the queen worth having going into winter. That's not instinct running blindly. That's a more specific quality assessment than most beekeepers apply when they order a replacement. If you found Supersedure cells and made a decision, left them, removed them, found 2 queens and didn't know what to do, tell me below what you saw. Because every beekeeper who learns to read that mid-frame placement correctly is one fewer beekeeper handing winter a colony that didn't have to fail.